Welcome to our educational video on the second law of motion. In this exciting journey, we will explore the principles behind one of the fundamental laws of physics. So let's start. The second law of motion, formulated by the great scientist Sir Isaac Newton, provides us with valuable insights into the behavior of objects in motion. But did you know that the development of this law was a result of centuries of scientific inquiry? Let's take a step back in time and explore the history behind the second law. Centuries before Newton's groundbreaking work, ancient Greek philosophers like Aristotle and Archimedes made significant contributions to our understanding of motion. Aristotle believed that objects naturally sought their natural place in the universe, with heavier objects falling faster than lighter ones. However, it was Archimedes who laid the foundation for the concept of force and displacement. Fast forward to the 17th century when Sir Isaac Newton revolutionized our understanding of motion with his laws. The second law, specifically, was a significant leap forward. The second law of motion states that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. This can be mathematically represented as F equals ma, where F represents force, m represents mass, and a represents acceleration. To better understand this, let's take a closer look at the key components of the equation. Force, measured in newtons, represents the push or pull exerted on an object, while mass, measured in kilograms, refers to the amount of matter in the object. Imagine you're pushing a toy car. The harder you push, the greater the force applied. Similarly, the more massive the car, the more resistance it offers to your push. Acceleration, measured in meters per second squared, represents the rate at which an object's velocity changes. The second law tells us that acceleration is directly proportional to force and inversely proportional to mass. The second law of motion finds practical application in numerous everyday situations. When driving a car, stepping on the gas pedal applies a force that propels the vehicle forward. The greater the force, the faster the car accelerates. In sports, the second law explains how athletes generate power. When a batter swings a bat, they exert force, transferring it to the ball and causing it to accelerate. In conclusion, the second law of motion provides us with valuable insights into how objects respond to forces and how their masses affect their acceleration. It's a fundamental principle that shapes our understanding of the physical world. Thank you for joining us on this educational exploration. Remember, the next time you witness the effects of forces and accelerations around you, you're witnessing the legacy of centuries of scientific progress. Till then, take care and stay tuned for more upcoming content.